All right, thanks, Mary. Thanks, Scott. That was a nice presentation on the security implications for running Jupyter notebooks on TSC and sort of all the ways that you can sort of, um, compromise your research and your data on our system. So as Mary mentioned, we've put together a sort of client for the satellite reverse proxy service to sort of help facilitate your interaction with it, so you don't necessarily have to do all the manual commands that Scott was showing how to interact with the satellite. But yeah, so this is the Galileo clients, and I'll give you a quick overview of what it is, what it does, how you can get working with it on TSC. I'll give you some of the limitations. We haven't worked with it a ton on TSC yet. So this is sort of, you'll basically be sort of the beta testers for how well it's working on TSC. We've only recently added the PBS torque support for the scheduler here. So if you do find any problems, definitely provide feedback to us so we know how to handle that in the future, essentially. Okay, so yeah, this is kind of the session that I want to go through, and then we'll roll into the hands-on session once I'm done giving you the overview of Galileo and how to use it. So, I mean, I think we kind of covered this, but basically Galileo is a shell script utility, essentially, to help.
Marty?
Yes.
We lost you there for a little bit. So will you go back and finish that last slide?
Sure. Yeah, I'll just repeat the outline for today's session, essentially. So yeah, so I just want to do a quick overview of what Galileo is and how it works. Give you some quick tips on how to get started with Galileo and the essential elements you need to provide Galileo to get your Jupyter Notebook session started. I'll cover some of the limitations of Galileo in its current state. This is a prototype that's still being sort of developed and is changing, every week for the most part these days. So definitely keep that in mind as you begin using it. And as I said, you'll basically be beta testers for us on TSC in the sense where it's only recently been integrated with support for the PBS-based torque scheduler that you interact with on TSC. So after I cover these bases, take any questions, and then we'll roll into the hands-on session. And anybody who wants to stick around and ask questions and run some examples that I'll cover in this session, or if you have a notebook you want to get running, we'll try to help you out. So, okay. So yeah, what is Galileo? So Galileo is simply a shell script based utility that'll help you launch your notebook session on TSC. And it'll basically, the idea is to allow it to orchestrate all of this interaction with the satellite reverse proxy service and your batch scheduler, which on TSC is PBS torque, to start your notebook server, and then output this sort of one-time token authenticated HTTPS connection for you. That basically, once you run Galileo, you'll get a link to your notebook and you'll just paste that into your browser and be done. So it's going to be a little bit more complicated than that, but I've updated all of the documentation for Galileo recently as well on the GitHub site here. So definitely take a look at that after today's talk if you're interested. Just a quick history and design. So this is sort of our second generation utility script for the satellite reverse proxy service and launching Jupyter notebooks. There was a first generation one that maybe some users here are familiar with, this Start Jupyter utility that was developed by Mary and one of her students. The sort of impetus for Galileo was to sort of expand the capabilities of that initial prototype from the Start Jupyter script to support, we have the Expanse user portal. So if you're an Expanse user, you can actually use Galileo from the web portal there. And also just it's a little bit more convenient. Sort of some of the key features of the design here were to not only recreate the interactions with the satellite service that were needed to secure your notebook, but also increased the flexibility for users to configure their software environments. It was a very manual process if you were using the Start Jupyter notebook script. This is a little bit more flexible, and it'll generate this batch job that needs to be submitted to the scheduler on the fly for you. And it's all sort of command line argument driven. So if you need to use different options, you just put them on the command line to your Galileo launch command, and you submit it to the scheduler, essentially. Submit your job to the scheduler that way. And it's fairly easy to get started pretty quickly on TSCC. So these commands will work for you if you want to run them yourself. So essentially, the first step of using Galileo on any of the systems at SDSC right now, there's not a module that you'll load. You just need to put the path to where the Galileo is installed. So there's a central installation on every SDSC system right now on TSCC. This is the path to where the current version of Galileo is available. So you just need to run that export command to modify your path, and then you'll have the Galileo script in your environment that you can use to launch commands. And so the next thing you'll do to get started with Galileo is you'll launch your notebook session, right? And so to launch your notebook session, what you do is you say Galileo launch is the command that you'll use most frequently. And so you'll use Galileo launch, and then you provide it the command line options that you need to start your session. So the first one here, everybody is going to need to use is the account command. So this is how you would, just like your, if you're writing your batch job script and you have, your -A, whatever the name of your group is your account. I'm not as familiar with the accounting on TSCC, but this is kind of an example account from, say, Expanse, where you have 3 letters and then 3 numbers is your allocation ID, essentially, to charge the job to. So whatever account that you're going to charge your notebook session and the compute resources to, that's what goes there. Always on TSCC, you'll want to request some number of CPUs that you need for your session. So, this is just a simple example. So I'm just requesting 1 CPU that I need. So this will be run. Another thing about Galileo, there's always a default queue that'll be configured. So the default queue currently configured for Galileo is the hotel queue on TSCC. So that's why you don't see any reference here to hotel or condo or any other, or a home partition or something like that. But I'll show you how there's a command line to target different queues as you need as well, a command line option. But this is a simple example for everybody. Everybody should be able to run in the hotel queue. So that's why it's set to the default. So this will request 1 CPU from the hotel queue. We want to run the session for 30 minutes, and how I'm going to, so that's basically your resource request, right? So you always have to request a certain amount of resources and charge it to an account for your session. The next part of the command here is the second line. And the first command line option is to configure your software environment for the notebook session using the environment module system on TSCC. So if you're familiar with TSCC and you use the module environment, this is the pre-installed software that we put on the system and make available for you. And so already installed by default on TSCC in the module environments, in the SciPy 3.6 module, there is a copy of Jupyter, where you can run a notebook server. So that's what this is doing. I'm basically saying, I want you to load both the Python module and the SciPy module here to create this software environment that has Jupyter installed and all of the other sort of packages that I want to work with, right? In this case, there's one other option that I threw on here at the end, this -- Jupyter notebook. By default, Galileo is configured to launch a Jupyter lab environment. However, in this case, this SciPy module that's installed is, I think, too old, and there is no Jupyter lab installed. It's only the older Jupyter notebook interface, and that's what this option is there for. So if you're running a Conda installed version of Jupyter or some sort of container I'll show you. Most likely you'll have a Jupyter lab environment. That's the new user interface for Jupyter, the Jupyter project essentially. But if for whatever reason you want to use the older notebook interface, that's what this option here is at the end. So once you run that command, you'll get some outputs. It'll basically list your command line options that and the values that you've chosen for your session. But at the end of that output will be the URL that you want to copy and paste into your browser. Now, the key thing to remember is essentially this URL is like your password to your notebook, right? So you don't really want to share this publicly in any way while you're running your session. In theory, people can use it to get into your notebook as well. But copying and pasting this over your SSH connection from your terminal into your web browser should be pretty secure. So that's what you'll see. So those are the 3 easy steps. Pretty straightforward, pretty simple. I kind of already covered this. Again, there's a bunch of different command line options. The full list of the command line options are in the updated documentation that was posted last week on the repository there. Again, always keep in mind there's sort of these 3 sets of information that you need to provide when launching your notebook session. The first one is just, what type of compute resources do you want? How many CPUs do you want? How long do you want to run? That's pretty much all you usually need on TACC because, for example, if you're running on a GPU partition, usually the GPUs are allocated based on how many CPUs you choose. And also, I think the memory, Manu can correct me if I'm wrong, but also the memory allocated is also based on the number of CPUs requested. Since all the nodes are so different, it's hard to, do anything other than, I think, proportional to the number of CPUs, the additional resources, memories, or GPUs. And then, so in addition to compute resources, there's always some options that have to do with Jupyter specifically, like the notebook interface here. If you often use Jupyter notebooks, there's a notebook dir option to choose where your sort of starting directory is. That's supported by Galileo. But the most complicated part, I think, that confuses people in general, not even just with Galileo, is just how do I configure my software environment to run correctly on an HPC system? And so there's a bunch of different options, pretty extensive, that cover a few different ways that are most commonly used on our systems that we see that Galileo supports. And so right now, these are the 3 main ways to configure your software environments on TSCC with Galileo. So I've already showed you the first example was with this environment modules. So basically, if you want to module load any software from the pre-installed module environment that's available on TSCC, you use that environment modules command. If you're used to using containers, TSCC has Singularity. If you're running containers, you know that. So there's also a Singularity set of Singularity options you can use to point Galileo to say, hey, I have this complete software environment in my container over here with Jupyter. I want to launch my notebook server from within that container. You just point to that container and you can run your notebook server from the container using Galileo. If you're familiar with Singularity, it also supports converting Docker containers to Singularity containers. So that's another option if you're not familiar with, say, building your own containers. And then, as Manu talked about, Anaconda is a very popular way for people to maintain their software environments on HPC systems today. So there's also a bunch of different options for managing Conda environments when you're launching your notebook session with Galileo. So this is basically my last slide for the sort of lecture portion of today, and I'll show you some examples of running some sessions on TSCC after this slide. But just to remember, this is also a prototype for us right now, so we're developing it actively. So things will change over time. So if you're going to use this a lot, get familiar with, the documentation and, so when things change, revisit the documentation if something isn't working for some reason and it used to work. That could just be something on our side that, maybe we screwed something up in an update, which has happened already. So, but, things change for certain reasons. And one example is the different support for different environment shells. So if you're not using Bash as your shell, Galileo is not a solution for you right now. Essentially, it used to be, but we added so much to it that was too Bash specific that we need to sort of scale that back or come up with other solutions to make the shell support more distributed or more compatible with other shells. So if you're using Z shell or T shell, Galileo probably won't work out of the box for you. I can show you if you have those shells. I can show you. I can probably give you some modifications essentially that will help you launch your Galileo jobs. But yeah, so if you're in that situation, just email us and we'll work with you, because we need to fix that issue anyway long term. And then also keep in mind, as I mentioned, that Galileo has limited support for PBS tort commands. The design was really for Slurm initially, and how much support we'll put into the PBS side is sort of, we'll see how successful it is, because eventually I think TSSC is supposed to move to Slurm. So we don't want to spend too much time getting into the weeds of PBS if we don't have to. I think right now it's in a good spot where you'll find it very useful if you're using a lot of Jupyter Notebook sessions on TSSC. I think it'll work fairly well. So that's kind of my hope anyway. Okay, so if there's any questions, feel free to, I'll check the chat right now while I get set up for some examples. I don't know. Let's see. Okay. Yes.
There weren't any new questions, Marty.
Okay, great. So as we wrap up this, I'll do some of these examples. I'm going to keep this reference guide up for the hands-on session as we transition into that. But let me go ahead and, if you haven't already tried to start running some Galileo commands, let me run some for you and just show you what to expect. Okay. So first thing you have to do, I didn't put that in my 3-step process, but you need to be logged into TSSC, obviously. So the first step, if you recall, is you want to make sure that Galileo is in your path, right? So if I do a WhichGalyleo, let me clear this. Right, and there is no Galileo command. So that's what this, if you're not familiar with modifying your path, right? This is just a way to tell your shell to search for executables in other locations on the system. And so if I do a WhichGalyleo now, you'll see that it finds Galileo in the space in the location that I told it should find it. So now we have the command available in our environment. You can start launching your notebook sessions, right? So let's launch the simple one first, which was using the notebook server that's available just in the environment modules that are available on TSSC. So you just do a Galileo launch account. There's also shorthands for each of the command line options. So I could do a -A, I think is the correct one. If you don't want to do the long form, usually in the documentation, I just include the long form, so it's obvious what I'm typing. So I want 1 CPU. I want the time limit of, let's go 30 minutes. And I was going to use the environment modules, Python, SciPy 3.6. And in this case, since there isn't a Jupyter lab installation available within these environment modules, you have to use the notebook environment. That's what this last command is. In general, you won't have to use it if you have a modern, more up-to-date installation of Jupyter. But module environments usually just move pretty slowly. It takes a lot of time and effort for us to build and maintain all of the software packages that go in there. And so it's much more slow moving than, say, downloading the latest version of Anaconda that changes probably every week, it seems like. So as you can see here, when you run your Galileo launch command, right, it basically just tells you the command lines that you set. So I set my account to the builder group. That's my allocation group I'm in. Again, by default, I said that Galileo is always configured to use a certain partition or a queue on any system. So right now it's set up by default to submit jobs to the hotel partitions or the hotel queue on TSDC, because I believe everybody should have access to that. So that's what the example is for. And so you can see here, but if you look at my Galileo launch command, I did not explicitly include that, right? That's why it went to the default partition. So if you're just running in the hotel partition, you don't need, or the hotel queue, you don't need to add that command line option, right? Again, I set 30 minutes. I wanted to use the Jupyter notebook interface, not lab. And then I'm using these environment modules. So these environment modules are going to be loaded prior to my session starting. So if I just look at my job, it's actually running already. So I haven't opened my browser yet, but I'll copy that URL. And hopefully no one's typed it in already and stolen my session. But the job was already started, so you didn't see if your job hadn't started yet and you're waiting for the resources to be allocated to you by TSDC scheduler, right? You would see those progression of the green steps or the different steps on the satellite reverse proxy service. It would indicate that your job's in the queue and it's waiting for resources. Once your resources were allocated, it'll show the job running, and then it'll show whether or not your connection has been mapped and proxied through the satellite service. And once that's done, then your notebook session will pop up. Since my job was already running, all those steps had already happened, so it just took me straight to my notebook session here, right? So that's pretty straightforward, pretty simple, hopefully. So everybody should be able to run that example out of the box. It's just using software that's already pre-installed on TSDC, right? And of course, hopefully if you're working with Jupyter notebooks and you're here and you're interested, you know how to use Jupyter, so I'm not going to cover that. But I will just, one thing to keep in mind when you're using Galileo, when you shut down your notebook session, you want to stop the server, right? So in the old interface here, it's quit, and that'll basically kill the job on the scheduler. And so, it should, eventually go to the completed states. I can't, right? It actually stopped the notebook server. There's no more jobs. So the service is now unavailable when I refreshed it. And eventually the scheduler, it takes a couple of minutes for TSDC to catch up. I'm not exactly sure why. Not usually using TSDC myself. So, but I did notice working with this last week, usually takes a few minutes to shut down the sessions. But if it doesn't, for whatever reason, just make sure, or if you forget to quit or shut down the notebook server, and you can always just double check and make sure, QDEL your job so it's out of the queue, right? So you're not going to get charged for the resources beyond the time where you actually want to use the notebook service. Okay, so that is the first example here. So that's the 1, 2, 3 steps to getting something running. Now there's a bunch of different ways to configure your software environments, right? So Manu talks about Conda. I do a lot of work with Singularity. So there's a few Singularity examples here. So there's one where you download an R notebook. So someone asked about running R, and what I did for this example that you can actually find in the Galileo documentation. I've actually downloaded oops. I've already downloaded it, sorry. So you basically can, if you are not familiar with building your own Singularity containers, one of the nice things about Singularity is you can convert Docker containers. So if you're familiar with Docker containers and you have, some Docker containers you want to use, you can download them from Docker Hub or any sort of repository using Singularity. In this case, I've taken this Jupyter. The Jupyter project itself has a bunch of Docker containers for popular software that are available. So in this case, I just wanted to choose something other than Python. So a lot of people do like using R. I don't know how extensive this R notebook container is that they put out, but it's something if you don't know how to use containers, but you want to just give it a try, this is one way to get an R software environment set up really quickly. And then you can actually start working with Galileo, right? So you can see here this, instead of using the environment modules, the only difference in this next command is I'm pointing to the container itself that I downloaded, right? So if I go back here, I actually don't need that anymore because there's Jupyter Lab involved. Here, I just point, I use the SIF option. So this is Singularity Image File, is just the acronym. So if you just point to where the SIF file you want to run is located, as long as it has Jupyter installed, Galileo will interact with satellites, set up your batch job, submit it to the scheduler, give you back the URL, paste it into your browser, and if everything goes well, you just put it into your browser and wait for the resources to start. So let's go ahead and check here. So yeah, so we're just waiting for that to start. While we wait for it to start, if you do ever experience a problem where you think your notebook server should be starting and Galileo is not starting it for some reason, one way you can start debugging things yourself before you contact us, Galileo creates a hidden folder in your home directory, this .galileo directory, and stored within this directory are both you'll see both batch job scripts and the standard output files from the scheduler. So for example, the job that's waiting in the queue right now is probably this batch job script here. So you can look at what, Galileo is writing this batch job script for you and doing all the interactions, these curl commands to interact with the satellite reverse proxy service. You can see here it's starting your Jupyter Lab with all this other stuff that you need to get going using Singularity and the R notebook container that we told it, right? So you can, if you get familiar enough with Galileo, you can take a look at what the batch job script looks like. You think, did it generate the batch job script I wanted it to, right? Sometimes I keep forgetting to put my actual, account name in there, and I leave in the default sort of ABC123 account, and nothing happens. So you can make sure that the batch job script looks like it's what should have been generated. Then if the notebook actually, if the job actually started, you can then look at the output from the job, right? So you might see some sort of error in here, or maybe things got stuck somewhere when the notebook server was starting up. You might see an error there. So those are just two places to check if you run into any issues while you're getting familiar with Galileo. And let's see, notebook is still in the queue, I assume. Okay, it's running now. Okay. So let's see. Doing live demos is always difficult, right? There it goes. I'm like, sometimes it'll take like, as you can see here, it's been running for, the job has been running for almost a minute. That's kind of the refresh rates for the job, to keep checking with satellite to make sure the connection's ready and everything. So it's, so it'll take, a minute or so. If it takes more than 2 minutes for your notebook to start up once the job is running, then you might have an issue. That's when you might need to start doing some debugging. So you can see here, right? I started this R environment from this, Docker container that someone built for me. I didn't have to install any software myself. I just had to download it, right? And then I can start using R in my notebook here. So, and if you want to check what's installed, I think if I remember correctly, I think that's the way to do it with R, but let me see. Maybe someone with R experience. I think that's the right way. I forget off the top of my head. I thought that was the way to check for what R packages are installed. But anyhow, we don't need to mess around with that for right now. So there's a bunch in the chat. Let me just see what we're talking about. I don't know if anyone wants to catch me up. Okay.
I've answered a few, but there's one about why did you use a gigabyte? Is it a default or for some special reason?
So yes. So if I scroll up here, so you'll see, the memory is a little tricky right now on some of the systems. So right now, what you'll see by default, if you don't specify any memory, is you'll see -1 actually, right? And so that's just a default setting that means, if you look at the documentation, essentially it means the scheduler will set the memory for you, right? So if I ask for 1 CPU on whatever node that my job lands on, Suba or Manu can correct me if I'm wrong. If I say I want this many CPUs, the scheduler on TSDC will allocate a default amount of memory. I don't know what that is. I think it depends on what node you land on, and sort of if you're landing on your specific research groups, condo nodes. I think the amount of memory that you get is going to be different. That's why it's sort of difficult to say how much memory you have without being more specific.
So Marty, I think it is proportional to the number of cores you request, but
yes,
I could be wrong. I think that is the general rule. If you have, say, 128 gigs and you ask for 6 cores, you get 128.
Yes. So yeah, the reason for this setting is basically allowing the scheduler to set the amount of memory. So if I go into the documentation, you'll see right. So amount of memory in gigabytes required for the job. You can set it and it will get passed to the TSDC PBS torque scheduler correctly if you want to explicitly set it. If not, the default value is set by the scheduler, and that's what this -1 means. So it's not actually setting it to 1 gigabyte. I just needed something there to basically have an integer value that wasn't, to check against essentially in the scripting. So, and there might be a better way to present that in the output here, but right now that's what that means. So hopefully that answers the question.
Marty, there's been a couple questions that I'll generalize to. What happens when you quit or shut down this notebook server when you use the file log out as opposed to kill, and then what happens to your work, and can you restart? Just a few questions, and maybe you can comment and give a few more details on that.
Yeah, sure. Right. So here, thank you. Someone passed me the right. Hannah, thank you. Yes, installed packages. I knew I was close. I just don't work with R enough. Okay, so you can see I'm in my R notebook here. So there's a few things, right? So here in the Jupyter lab environment, which I think most people are using these days, right? So there's a few things that will happen, right? So for example, what you don't want to do necessarily is just close your browser tab, right? But that still leaves the notebook server running, right? So I'm not going to do that. What you want to do to properly shut things down from within the notebook itself in Jupyter Lab, right? You'll go to File, Shutdown. That will shut down the notebook server. The scheduler will detect that your job essentially has ended. You know, it's just, remember, Galileo is submitting a batch job to the scheduler for you. So once it gets, you know, anytime you run the batch job through the scheduler, once it gets to the end of the job, the scheduler says, oh, there's no more commands to run. I'll just release these resources, send back, you know, whatever last output needs to be output to the standard output file, and it'll, you know, release the resources to be used by other jobs. So that's what you would do to correctly do it from your Jupyter Lab interface here. You do a shutdown, the job will basically end, and the scheduler will stop the job, and that's it. Now, if you do something else like log out, right? So if I just log out from the notebook, you know, if you've set up a password or you have the token, you can log back in, right? And it's not default to a blank password like Scott was showing in some examples that maybe some people set for some reason, which you should not do, right? You don't want to change your notebook session password to be nothing once you get your notebook session starting, or you're sort of defeating a lot of the purpose here. So, but right, once I do this and I close my tab, you know, you have not released the resources from the scheduler is the point here, right? So if I go back to my, yes, the idea is not to burn your allocation on idle resources, right? So my job is still running. So if you do that and you just log out or you accidentally close your browser tab, if you don't have the URL in for whatever reason, which I can't seem to scroll back up to my URL here, so I can't get back to the URL. So in this case, I know that I can't get back to, I don't really know what all the what the URL was and what the token was, so I can stop my job here. I think if I remember correctly, maybe if I go to my history, you might be able to find the URL. So that's one way if you forget, if you can't get back to it and you really want to. If not, just shut down your job and start a new session, right? Again, if you're working with Jupyter regularly, right, hopefully you're saving your notebook and your work regularly to your home directory or your Oasis scratch space or wherever. If you have project storage on the system, you know, you should definitely be regularly saving your work and modifications to your notebooks, right? It's just kind of just like writing a Word document. If you don't save it regularly and, you know, something goes wrong with the application while you're working on it, it's kind of the same issue. So anyway, hopefully that answers kind of those questions. But yes, try to be mindful of making sure that your jobs are not still running even though you've closed your browser tabs, right? So
yeah, our philosophy is that URL is a password to your files and folders and the system, and treat it that way.
yes. So I think, I mean, we're basically in the hands-on session here. I'll leave this, I'll stop here
Marty?
and answer any other questions. And I don't know how we want to do the hands-on session, but.
So
sorry,
Marty,
go ahead.
there's one more question, I think. Can you specify a specific node instead of like just saying nodes equal to 1? Can you say node equal to a node name?
Yes, I believe so. So here, let me try to show with that example if I can. So essentially, if you look at the documentation, I do have an example of this in the I think it's in the singularity section, but essentially it's this, what you'll use is this constraint command line option. So on TSCC, right, if you're familiar with the PBS nodes command, right, there's a list. So PBS nodes will basically list all of the nodes on the system and a bunch of things about those nodes and what's going on. One of the lines in that list is the properties, okay? And it's the only way I think right now you could target a specific node or type of nodes. That's the only way I've done it so far. For example, yeah, they don't. Yeah, I don't know if there's a specific. I don't know. I'll have to do some testing to see if I can get it to work on a specific name of a node, if that's what you're looking for. If you're looking specifically just for nodes with different resources, like if I want to run on a A40 GPU, right, I can do that, right? So here I would use, let me just go back to one of these commands. Just ignore that it's our notebook and we'll never use a GPU, but if you add the constraint command line option and you do A40 GPU, and then this is, I'm probably gonna, I'll show an example here, right? I think I only have access to this node through the GPU glean, if that's the right name of the partition, or queue. That's how you would sort of attach some of PBS node constraint essentially to your job. Let's see what happened here. What is the name? Sorry, I don't remember.
It's
what the name.
Glean. Sorry, I was.
Oh,
muted.
it's still just Glean. It's not GPU.
Yeah.
Okay. So I don't know if this node is being used, but I think it's the only node that has the A40 as far as I know. So I should end up on only that node. And I have tested this feature. So if you, as long as you target like the properties of a node that you want to land on, that should work. But yeah, the name of the node, I don't know. Anyway. So we might have to wait for that one. So yeah, I don't know how we want to do the hands-on session, TSCC
Yes.
team,
Yeah,
but we can definitely get started, I guess. I mean,
Yeah.
I can walk through other examples, or just we can, if people have more specific questions about their
The questions that there's one more good question. I think it's about from Suvik. If we have or are willing to launch Jupyter in our lab group queue at a specific node, can we do that? I believe you can. Isn't that right, Suba?
You can.
Yes, that's the question. I think that's what he answered. Like, maybe we cannot mention the name, but the properties, right?
Okay.
Yeah, so right, I'm not as familiar with TSCC as some of the others, but essentially, right, I think every research group has a home
Yes. Yeah.
partition, right? Or home queue. And so that's what you would do basically. If
Yeah.
whatever your home queue is, it'll take you to the right set of nodes that way. And if within that home partition you have nodes with different resources that you want to target, then use the constraint command, is what command line option is what I would do.
Okay, sure. Thank you.
So our thought on the hands-on, great questions, everybody, and we can continue that if that's the preference. You can go to Marty's repo and try to run Galileo, although I don't know, how fast you'll get your interactive node, but go ahead and give it a try if you want, and then see if you have any problems or issues. We could just be debugging your ability to use Galileo, and you're welcome to ask questions, unmute yourself. One thing you could do is, if in Zoom, you can go under preferences and choose to view the presentation and use dual monitors. And so that allows you to see all